Okay, this is going to be the second part to the chapter 15 and 17 post assignments or post problems. So I'm going to get into chapter 17 now, and the only problem I have from chapter 17 is 17.4a. The reason there's only one is because this is a fairly long and extensive problem. So let's get started right away. This problem says Bright Day Company produces two beverages, High Voltage and Easy Slim. Data about the products follows. So it gives us a bunch of numbers here for both problems, and then there is additional data from its two production departments, the mixing and bottling departments. So what is required? So first, we need to determine the cost of each product line using ABC. What is the cost, and then what is the cost per bottle for High Voltage and Easy Slim? And then number 3 here says if High Voltage sells for $3.75 per bottle, how much profit does the company earn per bottle of High Voltage that it sells? So let's start with the first one. So I made this table here. So on the far left-hand column, you can see all the different activities. So within the mixing department, there are liquid materials, dry materials, and utilities. And then within the bottling department, there are bottling, labeling, and machine setup. So then I have additional columns for expected costs, expected activity, and activity rates. So let's start filling this in using the information that we have. So it says that the liquid materials portion of the mixing department is expected to cost $2,304. So let's fill this in here. And then the expected activity is to create 38,400 gallons. So the cost is obviously a number value, dollar value, whereas the expected activity is going to vary depending on which activity it is related to. So with liquid materials, this would be measured in gallons. So then, once we have the expected cost and the expected activity, we need to figure out the activity rate. So this is a super simple calculation. All we're going to do is take that expected cost, divide that by the expected activity. So $2,304 divided by 38,400 gallons, and that is going to give us an activity rate of 6 cents per gallon. So that's the basic process of figuring this out. Now we have 5 other departments. So I'm not going to go through every one, but we're going to pull the expected cost and the expected activity from the information given, and then we're going to divide the two to figure out the activity rate. So for the dry materials, that is going to give us 55 cents per pound. For utilities, it's going to give us 36 cents per machine hour. And then getting into the bottling department, the bottle activity rate is going to be 40 cents per bottle. Labeling is going to be 3 cents per label, and the machine setup is $25 per machine setup. So again, all of these numbers are coming from the information given, and we're just calculating the activity rates here. So now that we have the 6 activity rates for each activity, we are going to figure out the cost for each one. So this activity column here, the first one on the left, that is all the same information from the previous slides, far right-hand column. So see 6 cents, 55 cents, 36 cents, etc. That is all that here. Now we're going to break it down into the 2 drinks. So the first drink is High Voltage, and that gives us how much activity is incurred for High Voltage. So let's start here. So the activity rate was 6 cents per gallon for the liquid materials, and for the High Voltage we used 1,400 gallons. So we're going to multiply the 6 cents times 1,400 gallons, and that is going to give us a total overhead assigned cost of $84 for the liquid materials activity. We're going to do the same thing for the rest of the activities. 55 cents per pound for dry materials times 620 pounds of dry material used is going to give us $341 in overhead assigned costs. Same thing for the machine hours, it's going to be $72. For the bottles, $5,000. Labels, $1,125. And then the setup is going to be $12,500. So calculated the 6 assigned overhead costs. Now we need to sum them up. So when we add those 6 amounts up from the previous slide, we're going to get a total overhead cost of $19,122. Now, we need to figure out the total overhead cost per bottle. That's what the question asks. So we have the total overhead cost for the entire beverage here, high voltage. Now we need to figure out that cost per bottle. So it says that we produce 12,500 bottles. That's our production volume. So the average cost per bottle, all we're going to do is take that total overhead cost of 19,122 divided by the 12,500 bottles, and that gives us an average cost per bottle of $1.53. So pretty easy, just a little division here. Biggest thing is just remembering which numbers we're going to use. Next, we're going to do the exact same thing with the easy slim problem. We're going to take that activity rate that we found using the first table and multiply it by the easy slim activity drivers incurred. So these were a lot higher. The liquid materials incurred, we used 37,000 gallons, 12,000 pounds of dry materials, 3,750 machine hours, 180,000 bottles and labels, and 300 setups. Multiply these amounts across and you get the following assigned overhead amounts. So same thing. We need to add all of those 6 overhead costs together to get a total overhead cost of $95,070. With Easy Slim, though, we produce 180,000 bottles. So that average cost per bottle is going to be found by taking that $95,070 in total overhead costs and dividing it by $180,000 bottles that we produced, and that gives us an average cost per bottle of 53 cents. So again, same thing, just different numbers as the high voltage drink. And then the final part of the problem says, if high voltage sells for $3.75 per bottle, how much profit does the company earn per bottle of high voltage that it sells? So let's go back to high voltage here. We figured out the average cost per bottle is $1.53. So let's go back here, and this is going to be a very pretty intuitive response and how to figure it out. So the price that we are charging per unit, per bottle in this case, is $3.75. The cost per unit is $1.53, so subtract that from the price that we sell it at, and that gives us a profit of $2.22 per bottle. So again, pretty intuitive. If you would get a negative number here, that would be a loss. So that is it for that problem, 17.4. If you have any questions about this problem or any of the problems that I went over in the last video from chapter 15, or just anything in general from these problems or chapters, feel free to send me an email. My email is cneyhart@uwm.edu.